Hey guys, let's go ahead and look at reactions. Right now we're just going to look at writing and balancing reactions. We will worry about predicting products, so if you remember doing that from honors chemistry, we will worry about that a little bit later. We're not going to do that right now. Right now we're just worried about writing out the reactions and being able to balance them, since that's what we are looking at for the stoichiometry quiz. So just to kind of review some key concepts, word equations, and then the skeleton equations. Remember, word equations are typically the sentences that contain the elements and compounds with keywords like reacts and produces and different things like that that help us figure out how to set up our skeleton equation. So solid aluminum would be Al parentheses S, S standing for your solid, Al being the element aluminum. And our reacts with those types of keywords represent our plus sign, and liquid bromine would be Br2, because remember, elemental bromine is one of our diatomics. L represents the liquid. Okay, reacts to produce is our arrow. That could also be yield or any other type word that means to form. Okay, so there's our arrow, and then solid aluminum bromide, AlBr3 parentheses S for solid. Remember that AlBr3 is coming from our cross and swap of ionic compound naming. So that's just kind of some review. Again, just looking at keywords, reacts are with or and typically represent your plus sign. Yield, produce, form are your arrows. Okay, so states of matter, solid, liquid, gas, and of course aqueous. States of matter are important because eventually we're going to have to write net ionic equations, and some of you should remember what that is, but being able to identify what is aqueous will help us be able to identify how to set up our net ionic equations. And again, we'll play with that a little bit later. We're not going to fight with that today, but just again reviewing what our symbols represent and then also being able to write them out properly. Okay, and of course, again, our diatomics. Remember, our diatomics are elements that exist in nature with two atoms of the same element together. There are 7 that you need to recognize. Hydrogen, which is right there. You have your nitrogen, oxygen, fluorine, chlorine, and bromine. That are all our diatomics. And remember, we can identify whether it's a diatomic or not if it's one of these 7, if it's in its elemental form, which we look for the name INE at the end of it. So our nitrogen or oxygen, but like fluorine versus fluoride, or chlorine versus chloride, nitrogen versus nitride, oxygen versus oxide, and hydrogen versus hydride. Those are kind of our key ways of recognizing whether they're going to be diatomics or whether they are going to be within compounds, and we need to use charges. Okay, so let's kind of take a practice at this. We have aqueous sodium hydroxide. Okay, well, sodium hydroxide, if we go back and look at it, oops, let's put the pen on here. Sodium is Na+1, hydroxide is OH minus, so if we cross and swap, we're going to get NaOH. Okay, and of course, you're always welcome to put hydroxide in parentheses to identify your polyatomic ion. That's up to you. And of course, we do have aqueous, so AQ in parentheses. Reacts with is our plus sign. Okay, then we have aqueous calcium bromide. Well, calcium Ca+2. Bromide is Br -1. Again, notice that IDE represents that it's in a compound, not INE as a diatomic. So cross and swap here, and we're going to get CaBr2. And of course, this again is also aqueous. To form represents our arrow. So we'll draw our arrow here, and I'm going to enter down into the next line to write the products. To form aqueous sodium bromide. Well, again, sodium bromide. I'm going to just erase the hydroxide right here. Sodium's +1, bromide's -1. So our compound is just NaBr. Okay, and represents our plus sign. Oh, sorry, forgot the aqueous. Don't forget states of matter. And represents our plus sign, solid calcium hydroxide. So I'm going to get rid of the bromide here. OH minus, cross and swap here. And we're going to get CaOH parentheses around the OH this time. You will need them with a 2 on the outside of it. And of course, this is a solid. So there is our skeletal equation. Okay, we can practice some more skeletal equations in class if we need to, but here are some if you just want to take a second, look at them, pause the video, and then you can practice them and bring them in and ask questions if you want to, but I'm going to skip on for right now. Okay, Remember that balancing and stoichiometry is all based off the law of conservation of mass, which mass is neither created nor destroyed. So basically, when we're looking at these, when we're balancing reactions, the mass, or the number of each atom on both sides of the equation, should equal each other. So that's what we're using to actually balance chemical equations. Okay, so something that can be a trip up that a lot of people do is don't ever mess with the subscripts. Leave the subscripts alone. All we're adding is the coefficients, which remember is the big numbers out in front. It's what we're basically multiplying the compound R elements by. So looking at this, the first thing we're going to do is count up the atoms on both sides. Remember that due to the law of conservation of mass, the atoms on the reactant side should equal the atoms on the product side. So we count up the atoms on both sides. So sodium here, there's no number after it, so there's 1 sodium. Chlorine here, there's a 2 after it, so there are 2 chlorines. Sodium here, there's 1. Chlorine here, there's 1. So if I wanted to balance this, I need to think of multiplication. So I've got 2 chlorines here, 1 chlorine here. What can I multiply NaCl by to give me 2 chlorines? Well, that's going to be a 2. But putting a 2 here also changes our sodiums. It doesn't just change our chlorines to 2, it also changes our sodiums to 2. So once we have sodium to 2, we have to jump back over to this side and look at that side. We have 1 sodium versus 2 sodiums. So again, what do I multiply 1 by to get 2? A 2. So once I have that 2 there, I can change this to 2. Now I have 2 sodiums, 2 chlorines, 2 chlorines, and that guy is now balanced. Okay, so again, let's just practice a couple of these, make sure we can do them. Okay, sodium, there's 3 here, there's 0 here. So we can throw a 3 out in front. Not 0, I'm sorry, there's 1 there. There's no number there, there's a 1. All right, so 3 sodiums, put a 3 out there, it gives us 3 sodiums. Now, our nitrogens, there's 1 nitrogen here, 2 nitrogens here. Well, that means I need a 2 to multiply the 1 here to get 2. Now that causes a problem. This 2 also goes to my sodium, so 2 times 3 actually gives me 6. So it's okay to go back and change numbers that are previously there, that you've already put there. So by doing this, that gives me 6 sodiums and 2 nitrogens. Well, I have 2 nitrogens, how can I get 6 sodiums? By putting a 6 out in front. So that guy's now balanced. Okay, so sometimes it may help to look at the whole picture before balancing one. I would have seen that I had a 2 here and a 1 there, and by putting a number in front of here, it would have affected my 3 sodiums. So I would have balanced my nitrogens first, technically, and then balanced my sodiums. But that's kind of a trick of the trade, if you will, that you'll get used to being able to do. Okay, let's do our lithium reaction here. Let's go ahead and write it out. Okay, so first off, we have solid lithium. Okay, well that's Li, S, plus reacts with water, H2O, and of course water is a liquid unless otherwise stated, to form, that's our arrow, aqueous lithium hydroxide, LiOH, aqueous, plus hydrogen gas. And hydrogen is one of our diatomics. We know it's an elemental form because it's not bonded with anything, so H2, and of course gas at the end of it. So now we go through and balance this guy. Okay, so 1 lithium, 2 hydrogens. Careful here, notice the hydrogens are split. 3 hydrogens here, okay, 1 oxygen and 1 oxygen. Because the hydrogens are split, I would typically leave those for last, but we have a problem here. Lithium's already balanced and our oxygen's already balanced. So our hydrogen is the last thing we can look at. So what I typically do here is go, okay, I've got an even number of hydrogens over here and an odd number of hydrogens over here. I can always make an odd number even by multiplying by 2 or an even integer. I cannot ever make an even number odd. It's not going to work. So what I'm going to go over here and start with is making this guy even. So what this does is it gives me 4 hydrogens, 2 here and 2 here. Okay, that also gives me 2 lithiums and 2 oxygens. So I'm going to go back and fight with my lithiums. So 2 lithiums, 1 over here, 2 here. Okay, also my oxygens, 2 here, 1 here, throw a 2 out in front. Now what that did is it gave me 4 hydrogens. Well, 2 plus 2, 4 hydrogens. It's already taken care of. Okay, and this guy is with our polyatomic ions. Remember, with our polyatomic ions, don't try to count them as individual elements. Treat them as one thing, and it may be very helpful, especially if they're on both sides, it may be very helpful to put the polyatomic ions in parentheses so you can kind of see it a little bit better. So for example here, nitrate, NO3, there's one nitrate. Over here, there's two nitrates. Okay, so I can throw a 2 out in front here, and that gives me my 2 nitrates to match up. It also does give me 2 silvers, so throw a 2 in front of the silver, and this guy is now balanced. So that is it for balancing reactions. Let's look at some stoichiometry.